All right. So, good evening, everyone. Whatever your time zone is, welcome to today's class. Um, okay, we already have instructor on the call. Please go ahead and drop a message on the Discord server so that others can join in. And I think we're good to go, basically. So on the call we have Samuel. Samuel happens to be the lead solutions architect at I think Keke Limited. I hope I get that right. Hello, Samuel. Thanks for being here. Good evening to
Yeah,
you.
yeah. Good evening, Amaka. How are you doing?
I'm good.
Yes. So on
All
this
right.
end, I have the pleasure of being here. We can learn and go through networking and the security side of AWS together. Yes. So I think, Amaka, we can now start off.
Yeah, we can now start off. So if you're sharing your screen, let me know so that I'll just bring it up.
It's okay. Once I do, then I'll tell you. But right now, I need us to just touch base and understand. Okay, we say we want to cover about AWS networking. First of all, what's networking? A network is defined as a set of devices that share resources that use common communication protocols over interconnections to communicate with each other. I know basically for us to be able to come to such a platform, we are utilizing a network in our in our different countries and in our different zones. That's why we can be able to now have, let's say you got bundles, you got a Wi-Fi. That's a connection. That's a network. And when it comes to, let's say, internet network connections, those ones, they're designed for telecommunication network technologies. Uh, there are types of networks. The reason I'm starting at this point is I don't want to dive direct into the AWS networking without us understanding, okay, first of all, what are networks and what does it entail? Networks, we have the physically wired, optically, and the wireless radio frequency methods that are used to create networks. So when you're designing, building, and troubleshooting your network, you will be using a network topology type. In your design, you need to be able to visualize the way data is flowing to understand the flow of traffic between points in your network. Let's say for AWS, it offers maximum flexibility in Amazon VPC network design. I'm coming to explain more about what's a VPC and the network designs that come along with it. The network designs that, let's say, being a network engineer for quite a while, the network designs that I've used and been able to teach about, and I've also learned about them. We have we have point to point, bus topology, tree topology, hub and spoke, mesh topology, ring topology, hybrid, many more. Let's say, for example, let's start with point to point topology. The point-to-point topology is a private data connection securely connecting two or more locations for private data services. A point-to-point network is a closed network data transport service that does not traverse the public internet and is inherently secure with no data encryption needed. If you go to bus topology is where we have one coaxial cable that's used to create a bus network. It is important to know that this single cable and with a break on each cable is where the links from different network ports connect directly to that cable. It's like we have, let's say, let me use like a highway. In Kenya we have several highways, and I'm sure in different countries we have highways. We all have, let's say, exits, we have entries. Picture like you have one highway and you have entries and exits. Now those entries and exits, they lead to a network port. So if we had a network, that would be known as a bus topology. Let's come to mesh topology. This one is what is mainly used by many people, especially in terms of community networks here in Kenya. Mesh topology, yeah, this is where network ports are interconnected to each other without having a single point of connection. Like let's say we have network port A, B, C, D. We interconnect A to D, B to C, A to D, all over like we don't have a way to control it in such a way. Uh, in AWS, this design is used when it comes to VPC peering, and we use it to avoid. We use it when we come to using services such as the transit gateways. We'll be getting to that so that we describe more about the transit gateways. Ring topology is where, let's say, you use the same example, we have network ports A, B, C, D. Ring topology is where we want to connect A to B, then B to C, then C to D, then D back to A. You see, basically, even from a theoretical point or a logical point, you've already made up a ring. Let's come to a hybrid topology is where you're going to use one or more topologies. Say I want to use the bus topology and mesh topology. Say I want to use the point-to-point topology and the bus topology. Say I want to use bus topology and the ring topology. That's a hybrid. That's a hybrid topology that we'll be implementing. In networking, we have protocols for us to be able to work. And some of the protocols, they are divided into three. We have the management protocols, the network communication protocols, the network security protocols. Let's say, for example, the one that network protocol that most people are familiar with. Even when you're at your job place, you're told, yes, you're going to access the internet, but make sure what you're accessing, it has an S in front of the HTTP. You're not told, okay, what's the meaning of the S after the HTTP? So this brings us to the first two types of network protocols that we have. We have the hypertext transfer protocol, the HTTP, yeah, and the hypertext transfer protocol secure. HTTP protocol helps communication over a network. HTTP, it has a layer. HTTPS, the difference between this and HTTP now is HTTPS, it has a layer of security to your network communications. Hence, at our job places, what we are told, make sure what you're accessing has that S in front of it. So having a foundation of these protocols will help us understand if I send data from point A to point B, which protocols are in place and where are they working and at what point. So other protocols that we have are the file transfer protocol, mostly known as the FTP. Yeah, this one is used to facilitate efficient and fast transfers. Yeah, we also have the transport layer security. Yeah, we also have the simple network management protocol. Yeah, types, as I mentioned earlier, the main types of protocols and the groups that they are put in. We have the network communication protocols. This one, they include what I started with, the HTTP. We have the TCP, the transmission control protocol. This one is separates data into packets that can be shared over a network. We have the UDP, the user datagram protocol. It works the same way as the TCP by sending data from one point to another. Now the difference is TCP ensures that there is a connection before you now begin to transport the data, not just like the UDP, you just transfer the data without creating the connection first. Then we have the internet relay chat, which is a text-based communication protocol. For the network management protocols, we have the simple network management protocol, which is used to monitor and manage network devices.
Hello, Samuel.
Yes,
So I'd like to clarify. You're just explaining. You're not sharing your screen right yet, right?
yes, I'm just
All
explaining.
right. Okay, no
Yes,
problem. I just wanted to confirm.
that's in order.
Okay.
Yes, so we were the network management protocols. We have the simple network management protocol, which is used to monitor and manage devices. And the other protocol we have under network management protocols is the Internet Control Message Protocol, the ICMP, which is primarily used for diagnostic purposes. The network security protocols, which is the last group under protocols, we have the SSL, the Secure Sockets Layer, which is a network security protocol primarily used in ensuring secure internet connections and protecting sensitive data. We have the SFTP, the Secure File Transfer Protocol, and we have the Secure HTTPS. For us to be able to communicate on the internet, we have to have addresses. Say, for example, you want to come to where Samuel Mrekefu lives. You leave your town saying you want to come and visit me. Uh, you don't have my address. You will go around and wander and never arrive at my place. For you to come or I want to visit you, I got to have that address. It's the same way in networking. For you to send a packet from, let's say, point A to point B, you got to have an address of both sides. Let's say I'm at point A. I want to send to point B. I have to have the address of point B. And what we use in giving out the address, we use something known as the Internet Protocol addresses. Currently, we've been using more about the IPv4, the version 4 addresses, most of them, which are 32-bit numbers. Yeah, and as time has gone by, we now have IPv6 that we are using currently. I wouldn't really want to delve deep into the ranges of IPv4 because I believe this one we will explore it on our own, one step at a time, because we have the class A that starts from 0.00 to 127, class B 128 to 191, class C and such, and class D as you go on. Uh, for you to be able to use these devices, say for example, you live in estate A and someone from point B wants to come to your place, you live in estate A. In Kenya, we have house numbers. Let's say I live at, yes, for example, let's give it hypothetical. I live at H6. Uh, you'll come reach estate H. Then you're told, okay, now you're going to house number 6. It's the same thing we are going to use. In networking, we are going to give you an address. For us to be able now to give you different addresses, now smaller addresses from the main address. Now, like this place is known as H, as I said in my example. So H has an IP address, let's say 10.0.0.0/16. Now we want to give parts of H, like house number 1, we give it its own address. House number 2, we give it its own address. We will have to do something that's known as subnetting. Subnetting is the process of dividing a network into smaller network sections, and a subnet is a logical organization of connected devices. This helps to isolate groups of hosts together, which can improve routing efficiency, network management control, and network security. Subnetting it creates multiple logical networks that exist within a single class A, B, C network. These smaller subnetworks create a network of interconnecting subnetworks. Once we have these addresses, it's when now we can be able to go ahead and know how we are going to communicate over the internet. I want us to delve direct into networking on AWS. In AWS, for us to be able to network, we got to understand what's a VPC. I know we've heard of it before as I started, but we got to understand first of all, okay, what's a VPC? Yeah, a VPC. I'm looking for a way on how I'll be able to lead you guys direct so that everyone doesn't end up getting lost. Yeah, a VPC is a software-defined virtual private network. It's a service that you use to create secure private networks in AWS to host your applications and data. Your private services will run from this Amazon VPC. Uh, Let me just go here to. You'll allow me to share my screen. Two monitors.
Yes, I will.
Nice.
Bro, David, before we call.
Just a moment. Give me a moment. We want to share one single.
All right.
Yes, let's say for example, this is our network. Are you able to see my screen?
Yeah, I just put it up now.
Nice, I like that. I like that. I want us to use this to understand the networking on AWS. This is a VPC. This is now the virtual private cloud that we are using in this. Virtual private cloud is the regional zone that we have here. For us to be able, what I've been talking about, let's say about the subnets, you can see here we have a public subnet, the app subnet, we have the data subnet and such. This is just an example that I'm using. Public subnets, we are going to put there things that are going to be accessible from the public end. And for us to be able to have everything in the public subnet accessible from the public side, we are going to use a service that's known as the Internet Gateway. I've jumped here a section. In a VPC, we create subnets. We have a public subnet, we have a private subnet. Let's say, for example, this one we've given it a certain, how I'd say this is a house, this is an estate H. Picture this VPC as house H, an estate H. Now, for us to be able to subnet and have address one, we are going to put them addresses here on the private subnets. On the private subnet, the public subnet, the app subnet. This one is now where we are now using my example of the houses. This one can be house number one, house number two, house number three. You now understand why where I'm going with that example. Are we together?
Yes, we are.
Yes, nice, nice, nice. So, uh, when it comes to now the allocation of addresses in a VPC, we put them in our routing tables. Routing tables are the ones that determine what are we allowing into
Sorry,
our.
Samuel. Sorry
Yes.
for cutting you. Your screen went off.
Yeah, I removed it slightly. Yeah,
Oh, okay, no problem.
moved it slightly. We
All
are
right.
going to. Sorry. It's okay. So we are going to take addresses and we attach them to a public subnet. Take another address, we put it to a private subnet. Say, for example, we want
Um,
someone to say
right,
something.
we are trying as much as possible to make sure that we project short.
No, you can go on, Samuel.
Oh, it's okay. It's okay. So, say, for example, we want the public subnet to be able to access the internet side, the outside side, away from now the VPC. We are going to take the address, let's say 0.00/0, and we attach that one for the internet gateway. We add it to the routing table. Say we want to get another service or something else have access into our public subnet. We are going to take the IP address of that, let's say that service, and we put it deep into the routing table. Routing table, that's what we are using them for. Same to private subnet. You want it to access, you want something to have access to our private subnet. We are going to take that address and we add it to our routing tables. So which routing table uh makes routing table a core service in VPCs and working for the subnets. We understand on that. Feel free to shoot a question and write it up there. I can be able to answer for you. Uh, in private subnets, we put there the Amazon Elastic Compute Cloud. These are virtual servers that provide the scalable computing capacity while eliminating the need to invest in hardware upfront and can reduce your need to forecast traffic. I'm sure you've interacted with this because having that, I saw a certain lesson on the introduction to cloud computing. I'm very sure you touched on the EC2 and how they work. So that one I'm not going to spend a lot of time on that. And the other services, we have the Amazon VPC router, which is highly available and moves traffic from somewhere to somewhere else. Uh, we have the Internet Gateway, which is a regional resilient service ensuring high availability. The Internet Gateway sits on the edge of your Amazon VPC, the AWS public zone, and the internet to manage the traffic between your Amazon VPC, the AWS public zone, and the internet. The Internet Gateway is attached to one Amazon VPC, and one Internet Gateway works across all availability zones in a region. When an Internet Gateway is attached to a subnet, it creates a public subnet by performing a type of network address translation known as a static NAT. The Internet Gateway will allocate a resource with a public IPv4 IP address. Uh, Security on the VPC. One, we have the network access control list. Two, we have the security groups. Network control Network access control list is a type of security filter like a firewall that can filter traffic as it enters and leaves a subnet. These ones are more centered around the subnet. Security groups are more centered around, they're more centered around they're more centered now around the EC2. Are we able to get the difference? One difference about the security groups and the network access control list. Security groups are stateful and have inbound and outbound rules. But for the network access control list, they are stateless. I think these are one of the main security features that we use in the VPC. Uh, we come to just a moment here. We come to a virtual private gateway. It's a logical edge routing device that sits at the edge of your Amazon VPC. Virtual private gateway can be used with direct connect, VPNs, and act as a VPN concentrator on the AWS side of your site-to-site VPN connection. In our earlier lesson, there's a lesson that was there at 2 p.m. The instructor mentioned about the costing differences between having a direct connect and a site-to-site VPN. I'm just here to add a word to what is said about direct connect being more expensive than a site-to-site VPN. Direct connect, it doesn't require direct connect requires much more expertise than site to site. Another thing with direct connect is you are charged for that data going out there, like leaving out, going into the other service you are attaching to, you're charged for that. Whereas using site-to-site VPN connection, you are not charged for that. Let's say, for example, I said about the network ACLs being stateless. They affect traffic crossing the subnet border. They can be used explicitly to allow and explicitly deny traffic. They support IP networks and protocols. They are processed in order and so lowest number to highest number. Uh, let's move to the next section. Gateways in networking in AWS. We have several types of gateways in networking in AWS. One of them being the aforementioned internet gateway. We have the customer gateway, we have VPN gateway, we have direct connect, we have the NAT gateway, and we have AWS transit gateway. I think this one I mentioned it earlier. Then we have the virtual gateways. I think some of these ones I've mentioned and elaborated them earlier as I started. For internet gateway, this one I've elaborated there. Unless someone has a question, then I can be able to elaborate more on it. We have the customer gateway. These are physical software appliance that you own or manage in your own premises. It's used to, we use it when we are managing routing to and from our environment. We have the direct connect. It establishes connectivity that spans the Amazon VPCs across multiple AWS regions. We use this one to connect to our data centers or our on-premise environment. This one helps to transfer data at a faster speed than even the site-to-site VPN. The NAT gateway. These are network address translation service that enables instances in a private subnet to connect to services outside the Amazon VPC. Transit gateways. This one we use them. Let's say, for example, we have 5 VPCs. We want to connect them to each other. One thing with VPCs is if I have VPC A, B, C, D, E, F, G, let's say like 7 of them. If I connect them, let's say by the VPC peering, I connect them to A, I connect it to B, B to C, A to C to D. There's no way A will communicate with D or A will communicate to C. A will only communicate to B. This is one logic that when I was starting out on AWS that I didn't get right. But when you use a transit gateway, it allows connection. Let's say put it at the middle, then use a ring topology. Let's say the topologies, network topologies we covered up early, so that we have everyone connecting to one point. So A will connect to transit gateway, B to transit gateway, same. This enables VPC A to connect to directly to VPC D to connect directly to VPC D without having altercations in between. This is where the advantage of now using the gateway comes in. And one thing with this is it creates one-to-many peering connection through a central hub. The inter-region peering connects AWS transit gateways together using the AWS global network. It adds automatic encryption for your data, and your data never travels over a public internet. This is one very good advantage about the transit gateways. Also, it adds scalability, connectivity, better visibility, and control. Also improved security over peering connections. It can also be used to connect your AWS environment to your on-premise infrastructure, creating a hybrid network of AWS and the physical networks. Uh, the transit gateways adds a unique view for your entire network. even connecting it to the SD-WAN devices, the software defined wide area network. So one other thing that, or one other service that we implement in the networking side for AWS, we have the AWS private link, which provides private connectivity between the Amazon VPCs, AWS services, and your on-premise networks without exposing traffic to the public internet. Since your data does not get exposed to the internet where it can be compromised, you can migrate and use more AWS services with the confidence and keep your traffic secure. The private link, it makes it easy to connect services across different accounts and Amazon VPCs to significantly simplify your network architecture. You no longer have to choose between using a service and exposing critical data to the internet, which is something very amazing about this. There's a side known as the edge networking side. Edge networking side, it has several services in it. It has the Route 53, it has the AWS Global Accelerator. And what also comes with this is the CloudFront side. CloudFront, uh, let's touch on this edge networking. We want data to be transmitted to the user to the users with a low latency. Now this is where the side where CloudFront comes in for us. And the AWS Global Network, it defends and limits your exposure to attack by encrypting data, removing network hops, and controlling applications access. It also improves your application performance and integrates access to the AWS Global Network and the point of presence, what we commonly known as the POPs. Most of the AWS Edge networking services, they sit at the AWS Global Edge locations and are configured to connect and deliver data with a single digit millisecond AWS network latency. Let's start on the services that are on the edge networking side. As I started with the CloudFront side, it delivers data, videos, applications, and the APIs with lower latency and high transfer speeds. We have Route 53. These are domain name system for AWS. It sends your customers to your applications by translating names that users use into numeric IP addresses that computers use. Then we have the AWS Global Accelerator. This optimizes your user traffic and from the user to your application. This helps in caching. Once you get deeper into AWS, you begin to understand about caching. And if you're an IT guy, I'm very sure you understand what's caching. And now CloudFront helps now on the cloud end when it comes to this. Some of the network side, the network security services that we use at the edge, they are the AWS Shield, which protects us against DDoS attacks and the malicious web attacks with no additional charges to us. And the AWS WAF, which also has application protection to integrate your own rules by using the managed rules for AWS WAF. We have application networking. On AWS, you can improve your application network architecture with services that provide your traditional and modern application improved security, availability, performance, and efficient monitoring capabilities, along with the edge networking devices services. You'll forgive me for the devices side. I've been a network engineer, so when it comes to network, I'm used to devices when it comes to explaining them. The AWS also offers application networking services to ensure scalability, high availability, the improved performance and security globally. Once you can access, let's say, the AWS skill builder, you'll learn more about how to go about the application networking, how to use the VPCs, where can you fix the cloud fronts, the Route 53s, and how you can use them better. Part of what we use in application networking, we have the Amazon API gateway, which creates and maintains and secures APIs at any scale. We have the app mesh, which connects containers, microservices with application level networking. And we have the cloud map, which discovers access to the most recent resources and services. Yeah, when it comes to network security, AWS came up with the shared responsibility model. With the shared responsibility model, I like how the previous instructor came around this. The shared responsibility model, AWS takes security off the cloud. And what the customer now does, he takes care of the security of what he has in the cloud. Network security helps prevent attacks that could degrade your network's responsiveness and expose valuable data to unintended individuals. The AWS services grouped as network security when properly configured and can help maintain your network's high availability and responsiveness. These network security services can be configured for always on detection and automatic inline threat mitigations to maximize availability and application responsiveness. The other services that we implement when it comes to network security are the firewall manager, which helps to centrally configure and manage your firewall rules. We have the network firewall, just like the other network firewall on premises, which helps in deploying network security access for your Amazon VPC. So in short, for network security, we have the aforementioned network access control list, we have the security groups, we have the firewall manager, we have the shield, we have WAF, and we have the network firewall. Yeah. Aside from that, we have just a moment. Aside from that, we have the AWS guard group. Yeah, which also helps in managing security on our end. So unless someone has a question, I think I've delved much deeper into networking side because I thought the previous instructor delved more on the security side and the monitoring side. So hence I chose to work more on the networking end. So over to you, Amaka, unless someone has a question on this. I know it's at night, so I tried as much as possible. We don't spend so much time this side because, yeah, we can end up not having people listening to us. Amaka, over to you.
Okay, can you hear me now?
Yes, I can.
All right, I said that's fine. You did a lot. There's a question here. It's currently on the screen. I don't know if you can see it.
Uh,
Can you
uh
see the questions on your screen?
yes, I'm seeing it.
Okay.
PPCs we use, let's say we want to put your application on EC2. You're going to put it on the private subnet. Let's say let's picture this, you've created your network in a VPC. you've already assigned the network, the IP addresses. You're going to put your VPC, your EC2 in a private subnet. Also your database, if you don't mind, or if you want to also create a different subnet and put it in a different subnet, you can go ahead and put it there. So let me understand your question about the use cases of VPC in EC2.
Okay. So,
Maybe
this
the
Dario, can
question
you
able
throw
to
more light on this? Sure, he
come
will
up again.
drop. No, I said he should drop a message. I think he should do that now. He can hear you.
Nice, nice.
All right. So, guys, if you have more questions, please go ahead and drop your questions. Also,
Yes.
Dario, throw more light on this. So you have roughly about 3 minutes to do that. Thank you. All right. Okay.
And
So
where a
guys,
person
also,
feels, sorry, Amaka, where a person feels is not really mastered well, or he may have missed up on a few points here and there, they may just, I think you may give them my handle. They can text me on probably my LinkedIn, and I'll be able to elaborate more in
all
anything they
right.
want on AWS.
All right. Thank you so much. So guys, we just dropped someone's handle on the chat, so you can do well to follow Samuel on LinkedIn. And like you said, you can reach out to him if you're confused about anything. Um so Temidayo, we're waiting for you to drop more explanation or give your question more context. Meanwhile, if you have questions, please go ahead and drop your question. At least we have about 3 minutes, so please do that. Go ahead and drop your questions. So, guys, we're waiting. Okay, so, okay. Yeah, so he dropped a follow up. It's on your screen now. Someone, can you see the question? It's on the screen now.
Yes, I'm seeing it. Huh?
All right.
When I said about subnets in a VPC, subnets, we have the public facing and we have the private. You wouldn't want to put an EC2 on a public subnet, because public subnet, once you put it directly to, you connect it directly to the internet gateway, the public will have access to that. And we've just delved into the security of what we put on cloud. You'll be putting your what you put on your EC2 at risk, and also exposing your data to the public. So you implement it by putting it on the private side, because the private side, there's no way someone can be able to have access to that unless you let them, or unless they've hacked into it and not ethically. That's when they can. Don't know whether I've answered your question right.
All right. So, Temidayo, if that answers your question, please go ahead and let us know.
You can feel free to even reach out to me. I can even explain it to him. I have up to also around 11. You can reach out to me via my LinkedIn. I'll be able to elaborate more and more on this.
All right. So,
Yeah.
Temidayo, you can reach out. Yeah. So, someone's LinkedIn handle is in the chat, so you can go ahead and connect with him as well on LinkedIn. So, guys, if you have more questions, this is your time. Go ahead and ask your question. If not, you'd have to reach out to Samuel via LinkedIn, and he doesn't mind. So while we're waiting for more questions, let's give it 2 more minutes. I would like to say thank you so much, Samuel, for coming on this call. Thank you so much for elaborating and teaching us more on AWS.
Mm. Yeah, I really appreciate it. Thank you. My pleasure, all mine.
All right. Thank you, guys. So If there are no other questions, okay, let's just wait till. I think it's safe to call it a night. So if you want to go out, you are free to party or do whatever you want to do. It's Friday. Okay. All right, guys. So okay, it says okay, Temitayo said well answered. Thank you. All right.
I
Okay. So I think that will be all for tonight. Thank you once again, Samuel. Have a lovely night.
thank you. I appreciate it.
All right. Bye, everyone.
Bye.